Hey everyone, this is Nick Jacobs, math instructor here at Yavapai College. This is section 6.5. I'm going to go through a summary of factoring. So pretty much everything that we've done so far, I'm going to do some random examples and just talk about what to look for when we are trying to factor. So let's go ahead. And so again, just giving you some guidelines for factoring and factoring different polynomials is the objective for this section. So I kind of gave two factoring summaries here. The first one I kind of made. This is for just some steps for factoring any polynomial. So first step, factor out the greatest common factor. That's always going to be the case if possible. The second step is kind of looking at how many terms the polynomial has. So if it has two terms, is it are they two perfect squares? Are they two perfect cubes? Maybe it's both, right? We're gonna usually do the squares first in that case. If it's three terms, can we factor it by inspection? So maybe is it a perfect, so is it a, is it one of the trinomials, right, that we can factor? If not, we can factor it by grouping. So we're gonna talk more about that. And then if it's four terms, again, we always ask, can we factor it by grouping, right? Definitely when it's four terms. So, and then after you've finished factoring, you always want to check, can it be factored farther, right? And then the final step is to check, right? And we would just distribute or multiply all the factors out, FOIL, if that's applicable, and then see if it matches the original. So the next table I had is from the book. Sorry for this text kind of here, the text here in the middle. But anyway, these are their steps. They just included some of the formulas that we've talked about. So difference of squares, difference of cubes, sum of cubes, and perfect square trinomials, etc. Remember, I wasn't requiring you to memorize sort of the perfect square trinomial formulas. We could just use grouping for that, but it can be helpful and it can save you time if you would like to do it that way. So let's go through some examples. So factor 6x to the third minus 36x squared. So we notice this is two terms right away. And then the first thing we might want to look for here is a greatest common factor always, right? So our GCF, you notice in this case is, looks like we have a 6 and then an x squared. And so what we do is we take that out, right, of both of those, and we see when we, and you can do this two ways, and I haven't talked about this probably enough, but we can divide this if we want. We can take 6x to the third divided by 6x squared, and that actually just leaves you with an x. Or when you multiply it in, right, we get the same thing. And then we keep the middle sign, and then 36x squared divided by 6x squared would just be 6 if you want to do it that way. And this would actually be your completely factored polynomial. I can't do anything else there. Another example. So again, look for greatest common factor. You can pause the video if you're following along and kind of, try to find it yourself if you want. But that's going to be 3x in this case. So again, I'm going to take out a 3x from both of those, or divide it. And I'm going to be left with x squared minus 25. And then we notice that the x squared minus 25, this guy is actually a difference of two squares. Sorry, my pen was kind of messing up there. And so we're going to kind of factor it like this. We keep the 3x, but x squared minus 25 is simply going to be x minus 5 and x plus 5. And again, we could check that, right? We could could multiply the 3x in here and then get an answer, and then FOIL that answer with x plus 5, and it should come up with what we originally had after everything would cancel, and it would. All right, next one. Factor 2x to the fourth minus 162. So again, I can take out, I notice I have two even numbers. I can definitely take out a 2. So let's do that. So I'm left with 2 times x to the fourth minus 81. We have another, so this is another difference of squares because 81 is a perfect square, and so is x to the fourth, right? I can take x squared times x squared to get x to the fourth, or we can do, right, the square root of x to the fourth is x squared. But doing that, we would have x squared minus 9 and x squared plus 9. And notice that x squared minus 9 is also a difference of squares. So that one breaks up into x minus 3 and x plus 3. And this is going to be your answer. And I'm not going to check that. I'm not going to, multiply all this out, but you can definitely do that if you want. All right, another example, factor this one, 8x to the third plus 40x squared plus 50x. So again, I always look at the coefficients first, try to find a kind of a whole number that I could factor out. And in this case, it looks like 2 is going to be the biggest one. Because it can't be 3, 3 doesn't go into that. Can't be 4 because, well, 4 goes into 8 and 40, but can't divide 50 by 4 evenly. It's not 5 because 8 or 5 doesn't go into 8. 6, no. 7, no. 8. 8 goes into 40, but 8 doesn't go into 50. 9, no. 10, definitely not. And usually you can kind of stop at 10, especially if you have 3 or more there. But so 2 and then definitely an x because they all have at least one x in there. So we take out a 2x. So I'm left with 8x to the third divided by 2x would be 4x squared. 40x squared divided by 2x would be 20x. And 50x divided by 2x is 25. And then we notice actually this is a perfect square trinomial. But again, if we didn't really know that, right, we would take those two numbers, the 4 and the 25. So if you didn't recognize that, multiply them together. That gives us 100, and we look for factors of 100 that add to 20, and we know that that's 10 and 10. So what I'm doing here is I'm just assuming I don't know that this is a perfect square trinomial, and I'm going to split that 20x into 10x and 10x. And then factor by grouping. So I'm going to group the two middle terms, right? And I'm going a little bit faster this video because we've done this, or sorry, I'm not going to group the middle ones. I'm going to group the two on the ends, right? And I'm going faster because we've done this before, right? So here on this one, 4x squared plus 10x, I can take out a 2x. So I'm left with 2x plus 5. And then this one, I can take out a 5. So I'm also left with 2x plus 5. And then we notice that I can take out, let's see, so this would be just 2x times 2x plus 5, and then times another 2x plus 5. So this guy and this guy go together, and then the 2x plus 5 goes together. And I can actually write the 2x plus 5s, those expressions, as 2x plus 5 squared because I have two of those. All right, factor negative 2y to the fourth minus 128y. Okay, so again, look for a GCF. And when you have a negative, try to take that out. Okay, so definitely negative 2 is going to go into both of those. I have a y in there, so I can factor that out. So this is going to be y to the third, and then minus, let's see, 128. Oh, that's got to be a plus because when I distribute it, it's got to still be a minus, but then this is going to be 64. Okay, and then y to the third plus 64, that is a sum of cubes. Sum of cubes, 2 cubes. And if you recall, we can look back at our formulas, but again, that's going to be, so if I have like, something like a to the third plus b to the third, right? That's going to break down into a plus b. Remember, so same sign, opposite sign, and then add a positive. There we go. And we just have to pick out what the a and the b would be. Well, in this case, it's going to be y, and cube root of 64 is 4. So it's going to be y plus 4. Y times y is y squared. 4 times y is 4y, right? And then 4 times 4, 4 squared is 16. So this is going to end up being negative 2y times y plus 4 times y squared minus 4y plus 16. And that would be the answer. Again, I'm going a little faster, so just make sure, go back to other videos, double check if you're unsure of some of the steps. All right, this one has 4 terms. So again, when something has 4 terms, I'm going to think grouping. So I'm going to group like so, just making sure all the signs are still good when I would distribute this negative. And then I'm factoring. So I can take out an x squared here. I'm left with x minus 7. And we can take out a 4 here. So I'm also left with x minus 7. Because again, when I would distribute the negative 4, I would get the plus 28. I know that's can be a little bit confusing sometimes. But our like terms or common factors here are x minus 7. So I put these two together, and then the x squared minus 4, I put that together. But notice that this guy is a difference of squares. Okay, so I can break that down a little bit more into, well, the square root of 4 is 2. So just x minus 2 and x plus 2. And that is it for that one. Next example, 12x squared minus 75y squared. So neither of the 12, so I have 2 terms, neither of them are, right now at least, perfect squares. So I can't look at that, but I can still do step 1, right? Look at the GCF. Well, I think 3 goes into both 12 and 75. So if I take a 3 out, I'm going to be left with 4x squared minus 25y squared. And now this guy is a difference of squares. Because 4 is a perfect square, x squared is a perfect square, 25 is, and so is y squared. Well, what is the square root of 4x squared? So what times what gives you 4x squared? Well, that's 2x. And what's the square root of 25y squared? Well, that is 5y. So I would have 2x minus 5y and 2x plus 5y. And that would be it. I believe this is the last example, and it is. Save the best for last, right? So this one is going to be, well, it's 4 terms. Let's try grouping. Okay, we can kind of think in our head, if we group it like it is it gonna work? Can I take something out of those? And I think it will. So let's do this. Careful of these signs again, right? This is going to be a negative because you want, when you distribute, you want it to match what it originally was. And then here in this expression, I can take out definitely a 3 from 3 and 27, and then an x to the third. So I have x squared minus 9 left over. And then take out a 3, and I have, again, x squared minus 9. Again, when you distribute this negative 3 to the negative 9, negative 3 times negative 9 is positive 27. That's exactly what you want. You want it to match the original. So I have, let's see, oh, 2x² minus 9s. So I can combine those, right? We're still grouping. And then I have an x³ minus 3. Oh, you know what? I missed a step. I missed taking out the 3 at the very beginning. You know, and if you miss that the GCF is 3, you can still, you know, that's fine. You can still do it down here. I forgot about that. Okay, I missed that you could take out a 3 from each of these. Okay, so you can just do it here. I can take out a 3 from this one, and I actually just going to put it out all the way out in front, because it just works like that. This guy, right? This is a difference of squares because both of those are perfect squares. And actually, some people miss this one. This one, they're both perfect cubes, right? Even the number 1 is a perfect cube, right? The cube root of 1 is 1. The cube root of, well, the cube root of 1 is 1. The fourth root of 1 is 1. So you can take any root of 1 that you want, right? Because 1 times 1 times 1, however many times, is always going to be 1. So this one is actually a difference of cubes. Okay. Well, we know x² minus 9. Hopefully by now you're comfortable with the difference of squares. You just basically take the square root of this guy, and then you split up x² into x and x. But then x to the third minus 1, how is that going to break down? Okay. Well, again, we kind of go back to our, a to the third minus b to the third formula. Excuse me. And that's going to be a minus b times a² plus ab plus b². Okay. And so, well, what is our a and b here? Well, it's just x and 1, right? If we could take the cube root of those. So I just have x minus 1 times x² plus x plus 1, right? And here I did, right here, I really did our x times 1 to just get x. So I bring that down. And this is the answer for the last one. So that is a little summary on section 6.5. If you have more questions, that's really a summary on everything that we've done so far. So again, I went through a little bit quick. So if you have questions, let me know, and we'll see you in section 6.6.